but you're still going to get product rule. Now, I'm pretty sure I did this, but um, let's use the definition of a derivative to find the derivative of e to the x. I think I did this. Thought I did. Maybe I did it in my other class. Okay, shh. You guys in the back? So this is the biggest day for the teaching. Tomorrow is not a big deal, and Wednesday is just going to be the quiz and work time. So just bear with me today. Remember the definition of a derivative, because a derivative is nothing more than what? It's the slope between 2 points on a secant line, and you drag one point so close that you get the slope of a tangent line. And that's all that is slope. So I want to do e to the x. And this is just using properties of exponents. Whoops, as h goes to 0, sorry. And so it's going to be e to the x plus c minus e to the x over h. Oh, sorry, you're right. It's x plus h, because I was getting my c's in there. Thank you. There we go. That was going to mess me up. Now, I don't know what to do with that. So, and I don't even know how to graph that. So what I'm going to do, Noah, is I'm going to rewrite this as the limit as h goes to 0, and e to the x plus h is e to the x times e to the h. Then I have minus e to the x over h. I'm going to pause for a second. Because if you remember, and I think you do, but x to the m times x to the n is equal to x to the m plus n. Well, it goes back and forth. If I'm given x to the m plus n, I can rewrite it as to the n. Remember, you just add your exponents. I want to reverse it. And then what I'm going to do is factor out e to the x. And because I don't have a lot of space, I'm going to pull it all the way out the limit, because the limit has to do with h, not x. Okay, Zach? So can I do that? Can I pull that out of the limit operator? Does the limit affect the e to the x? Nope. So it's e to the x, because if that were an h, then I couldn't do what I just did. Casey, question? Times the limit as h goes to 0 of e to the h minus 1 over h. I factored out e to the x, I cover them up, and I get e to the h minus 1 as best I can. And then you say, well, what is that? Well, I'm going to graph this on my graphing calculator. Variables are dummy variables. I don't care what you call them. It could be a z, a star. On my graphing calculator, I'm going to graph this. I want the x to go to 0 of e to the x minus 1 over x. Okay, girls? And it is going to be 1, but how am I going to know that? I can't do it algebraically, because it's a transcendental function. Check. Because I don't want to graph this on my calculator with h's. I want to graph x's. This is still there. I'm just going to look at this section right here graphically. Okay, so I just want to see what that limit is. So I don't know any other way but to graph it. Why is this not affected by h? There's no h in there. It can't cancel because it's not e to the x minus e to the x. It's e to the x times e to the h. And when h goes to 0, you're right. I get e to the x minus e to the x. So I get 0 in the numerator and 0 in the denominator, and that's a problem. So I factored out e to the x, but I don't know what that limit is. So I'm going to get my calculator out. I'm all set to go because I've already done it today. So there's my function. No. I don't know why it is, but it is. Okay. We'll try that again. It should be okay now. Okay, so y equals, I have to do that. Okay, there it is. So I type in e to the x minus 1 over x. It doesn't matter if those are h's over h, but the function of my calculator is x's, so I'm in trouble. I can't put h's in there. But they're dummy variables. The limit's the same no matter how I do it. So I zoomed it because I wanted to look at the graph, and the graph was actually quite nice. It's kind of clear as to what it is. What is it? When I get at the table, it's really clear. It looks like it's 1, right? Try that again. There, that's at 1. Okay, let me look at the table because it's really nice then. So I do a second table set, and I want to start at 0, and I make my table step sizes really tiny because I want to be close to 0. And I go second table, and now it's clearer, at least it's clearer to me. It looks like it's getting close to what value? 1. Okay, so it's 1. So that's just a quick little proof. Not totally a proof because I had to use the graphing calculator. I'm sure there's an analytical way. In fact, I know there is. I know what it is, but I need a calculator to do it. So this is just 1. Yes, because it's e to the x times 1. So what's the derivative of e to the x? It's e to the x, because that slope is 1. Okay, I'm going to repeat what this says. I wish it wasn't on the sheet, but it is. So if y is equal to e to some function of x, then the derivative is, we have to use the chain rule now. So it's e to the same function of x times the derivative of this inside function, which is f prime of x. Well, that's what the quiz is going to be like. And I'll take one slide and I'll just write them all up there. So why don't I do it right now? Well, I'm going to write it again. I'm going to write that again. Okay. So if y equals e to the x, then y prime is equal to e to the x. What if y is equal to, actually I don't like that I'm writing it. The derivative with respect to x of e to the x is e to the x. Okay? Is that okay? Yes. The derivative with respect to x of e to the f of x is equal to e to the f of x times f prime of x. And I'll give you a sheet that will review that tomorrow, so then Wednesday should be easy. But you have to memorize this. Well, the next one in question that we're going to do is what is the derivative with respect to x of a to the x? Okay, I'm going to show you how we can get it, but you're going to want to memorize this, and I'll give you my little trick for memorizing it. Okay, so I got to go to the next slide, which is over here. Oh, before we do that, let's just practice real quickly. Forgot about that. What's the derivative of this one? This is example 1, so it's on the back side. So what's y prime? It's being difficult today. Yeah, it's having its issues. I can do it this way. It's no big deal. So y prime equals what? X plus x squared times 1 plus 2x. Because it's the chain rule. And later on in chapter 4, when we get to the applications of the derivative, you're going to be looking for horizontal tangents when y prime is 0. Is e to the x, or e to the x plus x squared, is that ever 0? No. Remember what e to the x looks like. E to the x looks like this. This is e to the x. Do you know what e to the minus x looks like? It's a reflection over the y-axis. Guess what? E to the x is always positive. E to the minus x is always positive. So the only place that this could possibly be 0 is when that's 0. But you'll see those applications as we get there. I'm just previewing them a little bit. Okay, so what about the derivative a to the x? We'll do it right here, but I'm just going to do the problem. Now, you got to really pay close attention or I can lose you because it doesn't feel comfortable to me, at least, to rewrite this the way I'm going to write it. Do you remember what e to the log of x is from last week? That's just x. Remember that e and ln are inverse functions, inverse operations. So if I have e to the ln of f of x, what's that equal to? F of x. So I can go backwards. I can start here and go that direction. So if I have a to the x, I can rewrite that as e to the log of what? A to the x. If e to the log of f of x is just f of x, to go backwards, I start with my and say f of x is e to the log of f of x. I know it doesn't feel comfortable. It doesn't, and I've been doing this a long time. It still doesn't feel comfortable to me. If I looked at e to the log of 9, it doesn't feel right to me, but I know what it is. It's what? 9. If you don't believe me, put on your calculator. These just undo each other. So I want to write a to the x as e to the log of a to the x. Now, is that okay? Well, you'll see why in a second. And what is e to the log of a to the x? Now remember your rule, your shortcuts? What is the log of a to the x? What can you do with this x? It's x times the log of a. Okay, so knowing that y is equal to a to the x, which is e to the log of a to the x. Okay, I'm just using this line right there. And now I'm going to bring that exponent down. So it's e to the x times the log of a. Now, a is just a number, like 2. Doesn't matter. It's just a number. Now can I take the derivative? Because this is just a constant. So what is y prime? Well, it's e to the x times the log of a times the derivative of x times the log of a. Remember, log of a is a number. Like, what's the derivative of 3x? Well, the derivative of 3x is 3. So what's the derivative of x times the log of a? Log of a is like a number, like 3. It's just what? It's just not x. If it were 1x, it would be 1. It's just the log of a. Remember, this is a number, like 3. No, we didn't have derivatives at the beginning of the year. I haven't gotten there. I'm working on it. So what's the derivative of x times the log of a? The derivative of this is just the log of a. Can I now change e to the x times the log of a back? I don't want that e. That's icky, right? Where is that? E to the, where do I have it written down here someplace? Right there. Yeah, do you see that? That's just a to the x. Because this is this. Y prime is equal to e to the log of a to the x times the log of a over here. And what is this piece going to be? Just a to the x. Oof. Because then that's why I said I don't feel comfortable with this either. We go back over here, over to this piece right here, and I remember e to the log of x is just x. So e to the log of f of x right here is just f of x. So I started with a to the x here and put it and reversed it. So it's e to the log of whatever my function was. Well, my function was a to the x. and it doesn't feel comfortable. It doesn't feel comfortable to me, and I've been doing this a long time. There's an easier way, which I will do tomorrow, but I won't do it today because we don't have the tools quite yet. We will in about 10 minutes have the tools to do it. These are equal, and then you can pull that x down there. But what do you have to know? What do you only have to know? Well, if you can't remember how to what it is, you'll have to remember how to do it. Oh, so what's the derivative of a to the x? Then I'm going to give my little thing again. Well, the derivative of all exponentials are exponentials back again times the log of a. Now, the way you can help you to remember, and surprisingly enough, my BC students that had me last year come back and say they remember it. My name is Lena, Lna. So when you remember that, it's a to the x times Lena without the a there, natural log of a. It's Lena. It's a family name. Yeah, it works, and he remembered it to this year. Yes, or Lena. Yeah. Now, think about it. If it were Dana, how is this any different? So it should be long A, but it is. It's a family name. So Lna. I see my name there every time I write it. Okay. What if I have, now you're going to have to memorize that. Tomorrow I'll show you a much easier way to figure that out if you forget it. I don't like writing things as e to the log of f of x because I'm just not comfortable there. But what is a to the f of x then? Okay, you still get the exponential function. That does not go away. You still get times the base ln of a times, what's last? F prime of x. And that's what the quiz is going to be like. Just these plain old ones. Now, does it work for e to the x? Because if this works for a being any number, then it should work for e to the x. Well, let's find out. The derivative of e to the x, if I use my new rule, is e to the x times the log of e. What's the log of e? 1. So yes, it does work. So everything you're going to see on the exam, you may see some 2 to the x's. You won't see much. You're going to see mostly e to the x, to be honest with you. Same with the logs. You're going to see natural log, not base 10 log, or any other basis. You'll see a little bit, but not very much. So the most important ones are e to the x and ln of x. Okay? So you got a list there now. So we have e to the x, a to the x. Now we need to find the derivative of the natural log of x. Yes? Yes? Right now, if you didn't follow that proof, I'll show you a different proof tomorrow. Okay, so where are we? Nope, did that one already. And this is how I wrote it here. I mean, you can write it this way too, but I just started it all over because I thought it was easier. So next slide, and we did that. We can't do method 2 yet because I have to do this. Sorry. What about the log of x? Y equals the natural log of x. I want to find y prime. Don't know what it is, but could you solve for x in terms of y? What is x equal to? Remember how we did this? You go the base to that exponent, because the log is an exponent, equals x. So it's e to the y. Now, can you find the derivative with respect to x? This is why we have the implicit differentiation. I can't do the inverse trig without it either. Okay, what's the derivative of x with respect to x? 1. Okay, Zach? What color do I want? Blue. So it's 1 equals the derivative of e to the y with respect to x is e to the y, chain rule, times the derivative of y with respect to x. If you see that now, think back when we first started implicit differentiation and how hard it was, and it's getting a little bit easier. I told you it would take time. So if I solve for dy dx, it's 1 divided by e to the y. But what is e to the y? It's x, isn't it? E to the, we said we took this original function here and we changed it. We solved for x. X equals e to the y. So in place of e to the y, I'm going to put an x. And that's the derivative of the log of function. Just 1 over x. Ready to go to my slide where I'm going to put them all together? Noah, ask. The derivative of x is 1. The derivative of e to the y is e to the y times the derivative of the inside function, which is dy dx. Solve for dy dx, you have to divide by e to the y.
Wait, can we do it again? Do a different one.
They're all the same. The derivative of natural log, I'll do a whole bunch, is equal to 1 over x.
The derivative?
And e to the y itself, look right here, is equal to x. So I just replace it back to the x's. So let's put this in our list. I'm going to find my list. It's here someplace. So I want the derivative with respect to x of the log of x. What is that? It's just 1 over x. That's it. I showed you why it was 1 over x. Now you just have to believe me. No, you're not going to prove it. I'm just giving you the rules. Now, what's the derivative with respect to x of the log of f of x? It's 1 over, sorry, it's 1 over whatever's in there, which is f of x, times the derivative of the inside. What's the derivative of the inside? F prime of x. You'll know it. You'll know that. You know e to the x is e to the x. Derivative of log of x is 1 over x. You will know it. It's not going to be hard. The a to the x's, those are hard. What about, you're not going to like this, what about base 10 log or other bases? Yeah, you're not going to like that one. Okay, let's see. I'm still on the wrong slide. Oh, there it is. Okay, what about that one? All I know is the derivative of the natural log of x is 1 over x. So can I change that log base a of x to a natural log? It's the natural log of x over the natural log of what? Remember change of base? A. Now a is just a number. That's all it is. So when I take the derivative of this, can I pull that log of a out? It's in the denominator, but I don't care. Can I pull that right through the operator? Or do I have to use the quotient rule? I can if you want me to. Want me to use the quotient rule?
Whatever you want.
Well, I don't want you to, I want you to understand I don't have to worry about that log of a. So it's the denominator times the derivative of the numerator, Noah, minus the numerator. What's the derivative of the log of a? No, it's a constant. It's like 3. It's 0. All over the denominator squared. So if I simplify that, that's the natural log of a times 1 over x, and then this is the natural log of a times natural log of a, because natural log of a squared. What happens to one of those? They cancel. Okay, do you know how to simplify that complex fraction? Simple. No, simple. What do you say? Multiply by x over x. So it's 1 over x times the log of a. Now, I don't memorize that. If for some reason I just can't. So what I do is I pull out the 1 over the log of a and multiply it by the derivative of the natural log function, because I know what that is. The derivative with respect to x of the natural log of x, so it's 1 over the natural log of a times 1 over x. Done. Okay, let's put that in our list. That's the last one. Then you have 2 more to learn, and then that's it on derivatives. Then we do the applications. Yes, you have to memorize these. I did the change of base. Remember the change of base? It's a log. If I want to change this to base b, it's log base b of the x over log base b of that base, a. That's the change of base. I chose natural log because I know what the derivative of natural log is, because it's 1 over x. Now, you can memorize this. I suppose I'm starting to memorize it, but I'm not really very good at that. I don't like memorizing. So it's the derivative with respect to x of log base a of x is 1 over x times the natural log of a. Okay, why do I don't like memorizing? What's the problem here? When I do a to the x, it's a to the x times log of a. When I do the log, it's 1 over x times log of a, all in the denominator. I get it all mixed up. So,
We need more applications.
oh, we are gonna. These are just the derivatives. We're gonna do them. Oh, you just wait. What about the log base a of f of x? It's 1 over whatever's in there, f of x, times 1 over the log of the base, chain rule, times the derivative of whatever's in there. Now you've got everything except for the inverses, inverse trigs. So let's do some problems. Yes, that's next week. As far as I know, it'll be Monday through Wednesday next week, because we have to review them. What is a logarithm? It is an exponent. That's all it is. Okay. Okay. This is the last page. I could do that, but let's do this one. And then I'm going to give you an AP problem that relates to that last question. Oh, this is having its issues today. I probably need to reboot or something. Yeah, it seems to always be like, you know what? That might clear it out. Let's see. Nope. Well, the green one works. Huh. Okay. There's an easy way to do this, and there's a hard way to do this. Well, the hard way is to use that change of base. I just changed the base. But there's an easier way, because you remember what this does? What does it do? Log base a of a, it undoes it. So it's just the sine of x. Remember, log base a of a to the f of x is f of x. It's just properties of logs. So what's y prime? Yeah, it's cosine x. Easy. If you use properties of logs, things get a lot easier. So I'm going to give you an example, and there's actually one in your homework like this. But let's graph the log function and remember what its domain is. And then I'm going to give you an AP question. Not particularly, not that bad. What does the log function look like? Remember? It looks like this. It gets infinitely large. It looks like it has a horizontal asymptote, but it does not. And so where is this? Careful. 1, 0. I do that too. And then what's the domain then? What's true about x? Whatever is in here must be greater than 0. Okay, so let's do a little problem. And I don't remember what year this was, but it was something like this. The natural log of x plus 1 over x. The first question is, find the domain. Well, that's not that hard. Well, be careful. The domain says that whatever's in here must be what? Must be greater than 0. Well, you get your point from making that statement. X plus 1 over x is greater than 0. Now, the next question is, do you know how to solve that? Well, I got to solve it. That's how you find it. You get the point for making that statement, even if you don't know how to solve that. Okay, Sophie? How do you solve it? What is it? And by the way, what does it mean to solve? I've been doing this in my algebra classes. Well, if I say x plus 2 is equal to 5, and I solve it, it's not the process of taking away 2. I solve it, and I say x equals 2. Am I right? Why? Why is that not right, Alexi? What's it? What? X doesn't, why doesn't x equal 2? I say it's 2. What's it? Tell me what it refers to. What algebra? There's a lot. The equation, if you substitute 2 in here, the equation is not a true statement. Yeah, you have to get all these words in there. Because if you know what solve means, then this is a very simple thing. So solve means to find the numbers that make the sentence true. And I start in algebra, but I didn't have you in algebra, so you probably didn't hear about it before today, probably. Make the sentence true. Because if you know that, you can solve anything. Guess and check always works. Well, unless it's nasty numbers. So I know that in algebra, you probably were taught to write inequalities like x plus 1 is greater than 0, x is greater than 0. This is how you probably would attack this, Noah. But you know what? There's another possibility. Numerator and denominator could both be positive, but they could also both be what? Negative. You guess what you have to do? You have to do all of these. You have to solve all of these and figure it all out as to what makes all that stuff true. I get overwhelmed thinking about it. So it's easier than that because I know what solve means. I just want to find numbers that make the sentence true. Now in New York, they have this Regents exam. And the New York teacher said, you can't do it. Can't do it my way. I said, why not? It's mathematically correct. They are wrong. It's mathematically correct. It's actually how you do a number of problems. Use a boundary method. In New York, they would accept only this kind of solution, which very few students would ever get right. They only have to pass one Regents exam in math, so they try to pass the algebra one. It's crazy. But anyway, I'm not going to do it that way. I'm going to use boundaries because I know that if I can find the boundaries for this, like where is the numerator 0? Where's the numerator 0? Negative 1. And there's another boundary where this function can change from positive to negative. And the denominator can't be 0 because that's a vertical asymptote. I've got a discontinuity there. So it's a boundary. I don't get to include either one. So all I do now, and a second grader can do this, is substitute in values for each one of these regions. If any number to the right of 0 works, they all work. If any number to the right of 0 fails, they all fail. That's all there is. So if I put 100 in there, is that positive or negative? Positive. I don't want to do that because I have to do fractions. I know how you like fractions. Well, let's do negative 100. What else do I put a negative 100 in here and here? Is it positive or negative? It's positive. Now, somebody in the last class said, oh, they'll alternate in sign. Don't assume that. Sometimes they do, sometimes they don't. In this case, they do, but we can show that by trying an easy number like, how about negative 1/2? And I know it looks scary at first, but when I look at this here, it's not that hard. That's positive, that's negative, so the result is negative. Now, I still haven't solved it. I have to make the statement of what makes that true, and all numbers from negative infinity to negative 1, and all numbers from 0 to infinity. You'll see this a number of times in this class. It's how we solve anything. But I just want to find the numbers that make the sentence true. Guess and check works fine. I just got to figure out where to guess and check because there's an infinite number of numbers. That's part A of the question. Part B, you don't want to see part C. Part B was find if y is equal to the natural log of x plus 1 over x, Find y prime of 1. Okay, so I got to find the derivative. Do you want to take the derivative of that? Well, what would y prime be? It would be 1 over x plus 1 over x times the derivative of the inside function, which makes me do what rule? Quotient. But there's an easier way. Why did I take all that time last week and do properties? Can you tell me what this is equal to with properties? Remember the log of a, over b is the log of a. Remember that one? Did you guys do the worksheet? Minus the log of b. I got to double check and make sure the answers are there. So can I make this the log of x plus 1? Because when you do the homework, I want you to use properties of logs because it's a lot easier. That I don't know. I got to check. Yeah, it'll be over there. Okay, so what's y prime? What's the derivative of that? What's the derivative of log of x? 1 over x. What's the derivative of 1 over x plus 1? 1 over x plus 1 times the derivative of the inside, which is 1. Now, is it easy to do y prime of 1? It's 1 over 1 plus 1 minus 1. 1 half minus 1, or negative 1 half. Because most likely, if this were the exam, and this has been the exam, you'll probably mess up the quotient rule. Somewhere in there it's going to get messed up. It can be done, but it's so much easier to use my properties. So much easier. So let's start the assignment together. Now, if you have your quiz corrections done, you can turn them in today. You can turn them in tomorrow. It doesn't matter. It's 9 through something odds. It's a lot of odd problems. So I'm going to use my little book. Pardon? And we did a lot of problems in class, in the other class. Okay. This is section 3.9. And you know, I know you have other things to do, so why don't you write them down and have it done? I was here. I got here about 7:10, 7:15. You guys got to hang around if I'm not here. I'm always here. Sometimes traffic gets nasty. Sometimes my dogs get difficult. Remember, I had 3 dogs I got to take care of before I leave. And 4 cats. Okay. Now, there's the easy way and there's the hard way. Now, the last class thought this was the easy way. It's 1 over 7x times the derivative of 7x, which is 7. You know, and it's okay, which is just 1 over x. Or it's the log of 7 plus the log of x. Do you remember that property? The log of a times b. It's the log of a plus the log of b. One more property before I go on, yeah. This is the easy way. What's the derivative of the log of 7? 0. That's just 1 over x. So if I have any constant times x, it's just 1 over x. Always. So you could put that in your list if you wanted. Here's another one. Of x to the r is equal to r times the log of x. It's way easier to do it this way. Let's do number 11. 1 over x. Okay, number 11. Again, this is easier to use properties of exponents because I can tell you the answer in my head. Yes, you can do this the hard way. Alexia should write it down. Should have written down all of it. Now remember, I do say this as a PDF so you can print it out again. It's 1 over x squared times 2x. I don't think the chain rule is always easy to do. I mean, that's not bad. But isn't this also this? Yeah, I'd have to change that to what? 2 over x, right? Probably have to write it down to get there. But isn't it easier to do this? This is 2 times the log of x. And you ignore the 2. What's the derivative of log of x? 1 over x. Well, 13 is kind of hard. It's probably going to be the hardest one on here, actually. So we might as well just do it. And the problem with this is you don't know what the derivative of absolute value is. And you don't need to. I got to give you that derivative. Okay? Okay, the derivative with respect to x of the absolute value function is the absolute value of x over x. Not proving it, I'm just saying that's what it is. They will not ask you the derivative of that on the exam. Just telling you. Okay, so first we start with the outside function, which is just the log. So it's 1 over whatever this function is, which is the absolute value of the sine of x. Because the derivative of the log of f of x is 1 over the function, whatever it is, times the derivative of that. Because that's what it is. Then I have to do times the derivative of the absolute value function. Well, that's the absolute value of whatever's in there over whatever's in there. That's just what it is. And another day, maybe tomorrow, if you want me to show you why it is what it is, I will. Then one more function times what? The derivative of the inside function, which is cosine of x. What happens to the absolute values? These guys cancel. And what, you guys remember what cosine divided by sine is? Not tangent. So that's the cotangent of x. I think that was the hard one. And you're not going to be expected to do absolute value on the exam. Now, they could have asked you just for the log of the sine of x, which, by the way, gives you the same answer. It's because you have 3 functions. It's 1 over this one, which is that, times the derivative of the absolute value. Forget the signs there. It's the absolute value of whatever's in there divided by whatever's in there times the derivative of whatever's in there. So 3 functions. That one was tough.
All that comes from sine vectors.
Absolute value. And they can't make it simpler. Like this one, I can make simple. I don't want to do this one as written. Yes.
Does it even matter? Or would it ever matter or be different as an answer for a derivative of having absolute value?
Well, it matters a lot of times. It just doesn't matter in this case.
Doesn't it always have to be greater?
Well, this is a log. But because this is a log, but it could just do the absolute value and it won't be. Okay. What about that one? Now, do you want to do that as written or do you want to use properties? I want to use properties. Because this is the derivative with respect to x of the log of x plus 1 minus the log of x minus 1. Then that's easy. What's the derivative of this one? What's the derivative of the log of x plus 1? It's 1 over the function times the derivative of x plus 1 minus, okay, Casey, what's this one? 1 over x minus 1 times the derivative of x minus 1. And don't worry about getting common denominators. It's fine. Just leave it. That is simple. If I did 1 over this quotient here times the derivative of the quotient, that would not be simple. I don't know. I don't look at the back. Let's do one more. I think I got time for one more, and then we'll be in the same place as the other class. But actually, we got through 19. So if you want to see the solution to 19, you can look at my PDF files. Okay, what do I have to do there? Yeah, product rule. Okay, Zach? So it's x squared plus 1 times the derivative of the log, which is 1 over x. That's it. Don't make it hard. Plus the log of x. Yeah, you guys tend to make it hard. Times the derivative of x squared plus 1, which is 2x. Now, I don't want to multiply the 2x times x because it's not. It's 2x times the log of x. And that's good enough. That's it. It always does, especially when you're texting. Okay. I'm here in the morning, don't forget. I have math team after school, which you all should be here for math team. But anyway, it's only an hour.